Have you ever looked up at the sky and wondered what secrets the air holds? How can we measure the invisible force that surrounds us? The answer lies in an ingenious invention: the barometer. This remarkable instrument has been unlocking the mysteries of the atmosphere for centuries. It allows us to quantify atmospheric pressure, a fundamental element of weather and climate. The barometer's journey is a testament to human curiosity and ingenuity. From its humble beginnings in the 17th century to the sophisticated digital versions we have today, it has revolutionized our understanding of the atmosphere. In this exploration, we delve into the fascinating history of the barometer, tracing its evolution from mercury columns to microchips. Join me as we unravel the story of how scientists, inventors, and dreamers unveiled the secrets of the sky. This is more than just a tale of technological advancement. It's a journey into the heart of our planet's intricate and awe-inspiring atmospheric system. The idea that air has weight might seem obvious to us now. We feel its resistance when the wind blows, and we see its power during storms. However, for centuries, the concept of atmospheric pressure remained elusive. Ancient Greek philosophers were among the first to ponder the nature of air. They observed that air could exert force. They witnessed this force in the way it could support objects, such as birds in flight or sails billowing in the wind. While they didn't have the tools to measure this force directly, their observations laid the groundwork for future discoveries. It was not until the 17th century that the true nature of atmospheric pressure would be revealed. This breakthrough came with the invention of a revolutionary instrument, the barometer. In the early 1640s, a brilliant Italian physicist and mathematician named Evangelista Torricelli took a giant leap forward in our understanding of air pressure. Working in Florence, Italy, Torricelli was intrigued by a peculiar problem. Why couldn't suction pumps raise water beyond a certain height? Torricelli suspected that the answer lay in the weight of the air. He reasoned that the air around us exerts pressure, much like water in a deep well. To test his theory, he devised an ingenious experiment. He filled a glass tube, sealed at one end, with mercury, a dense liquid. He then inverted the tube into a dish of mercury, taking care not to let any air inside. What he observed next would change our understanding of the atmosphere forever. Torricelli watched as the mercury column in the tube dropped slightly, creating a vacuum at the top. The mercury didn't completely empty into the dish. Instead, it settled at a specific height, about 76 centimeters above the mercury level in the dish. Torricelli realized that the weight of the air pressing down on the mercury in the dish was supporting the column of mercury in the tube. The higher the air pressure, the higher the mercury column would rise. He had invented the first barometer, an instrument to measure atmospheric pressure. This groundbreaking invention marked a turning point in meteorology. Scientists finally had a tool to quantify and study the invisible force that shapes our weather. The mercury barometer, though simple in design, provided profound insights into the workings of our atmosphere. Section 5. The Aneroid Barometer, a portable revolution. Torricelli's mercury barometer, while revolutionary, had its limitations. It was bulky, delicate, and posed a risk due to the toxicity of mercury. A more portable and safer alternative was needed. Enter the aneroid barometer, invented in 1843 by French scientist Lucien Vidy. The word aneroid means without fluid, and this aptly describes Vidy's ingenious creation. Instead of relying on a column of liquid, the aneroid barometer utilized a small, sealed metal chamber. This chamber, known as an aneroid cell, was partially evacuated of air. As air pressure changed, the cell would expand or contract, and these subtle movements were amplified by a system of levers and springs. These movements, in turn, moved a needle on a dial, indicating the atmospheric pressure. Section 6. Barographs, recording the ups and downs. The invention of the aneroid barometer paved the way for another significant advancement: The barograph. While barometers provided a snapshot of atmospheric pressure at a given moment, scientists wanted to track these changes over time. The barograph addressed this need by combining the aneroid mechanism with a recording device. In a typical barograph, a pen attached to the aneroid cell traced a continuous line on a rotating drum wrapped in graph paper. The vertical axis of the graph represented pressure, while the horizontal axis represented time. This innovative instrument allowed for the creation of visual representations of pressure changes over hours, days, or even weeks. Meteorologists could now study pressure patterns, identify trends, and refine their weather forecasts with greater accuracy. Section 7. Digital barometers. Precision and versatility. In the digital age, barometers have undergone a remarkable transformation. Today's digital barometers utilize electronic sensors to measure atmospheric pressure with incredible precision. These sensors rely on the piezoelectric effect, which is the ability of certain materials to generate an electrical charge in response to applied pressure. Digital barometers have become incredibly compact, often integrated into smartphones, wristwatches, and even high-end cars. Their versatility extends far beyond traditional weather forecasting. Hikers use them to estimate altitude, pilots rely on them for accurate altimeter readings, and scientists employ them in various research fields. With their ease of use, affordability, and remarkable accuracy, digital barometers have made monitoring atmospheric pressure more accessible than ever before. They represent a culmination of centuries of scientific progress, bringing the power of atmospheric measurement to our fingertips. Section 8. Barometers in action. Weather forecasting and beyond. The barometer's most well-known application is undoubtedly in weather forecasting. Meteorologists rely on barometric pressure readings to understand weather patterns and predict future conditions. High pressure typically signals clear, stable weather, while low pressure is associated with storms, rain, or unsettled conditions. However, the barometer's utility extends far beyond meteorology. Geologists use barometers to monitor volcanic activity, as changes in atmospheric pressure can indicate an impending eruption. Aviators rely on barometers for altitude measurements, ensuring safe navigation at varying altitudes. Furthermore, barometric pressure readings are crucial in fields like healthcare, where they are used to calibrate medical equipment and even assist in diagnosing certain medical conditions. The barometer's impact on our understanding of the world around us is both profound and far-reaching. Section 9. A legacy of innovation. From mercury to microchips. The journey of the barometer, from Torricelli's glass tube filled with mercury to today's sleek digital devices, is a testament to human curiosity and our relentless pursuit of knowledge. Each iteration of this ingenious instrument has built upon the discoveries of those who came before, pushing the boundaries of our understanding of the atmosphere. Today, as we carry miniature barometers in our pockets, we hold within them centuries of scientific progress. These unassuming devices connect us to a rich history of exploration and discovery. They serve as a constant reminder that the air we breathe, often taken for granted, is a dynamic force that shapes our world in countless ways. As technology continues to advance, we can only imagine what future innovations await us in our quest to unravel the remaining secrets of the atmosphere. One thing is certain: the barometer, in all its forms, will continue to be an indispensable tool in our exploration of the skies above.